Hey everyone, we're going to look at number 6, calculating the derivative of y with respect to x. And we're given this relationship between x and y. So we're basically going to find the derivative of y with respect to x. So we're going to find dy dx, and we're going to do that using implicit differentiation. Okay. Solving for y here is going to be a little bit tricky. You can solve for y. It will be, I think, a quadratic function in y. Look at two different y would be two different functions of x, but we're not going to do that. We're going to use implicit differentiation. So to do that, we take the derivative with respect to x of both sides. And remember, y is a function of x. Y is a function of x. Y is not a constant with respect to x necessarily. So we're going to let dy dx equal y prime for just convenience of notation. And over here, I'll take the derivative with respect to x of this side. I need to take the derivative with respect to x of 8y divided by x first and add it to the derivative x divided by y. Well, notice this is a quotient, and y is a function of x. And I don't know exactly what function of x it is, but I do have a quotient of two functions of x. I have to use what rule here? Quotient rule, right? Quotient rule. So remember what the quotient rule is. It's the derivative of that top function. What's the derivative of the top function? 8's a constant multiple. What's the derivative with respect to x of y? That's y prime, right? The derivative with respect to x of y is dy over dx. Y prime is the derivative that we're looking for, right? So this is 8 times dy dx, or 8 times y prime, times the bottom function minus the top times the derivative of the bottom function. Well, the derivative with respect to x of x is just 1. So again, we're taking the derivative with respect to x, not with respect to y. So this is just 1, all over the bottom function squared. Same thing here, quotient rule, right? Derivative of x, derivative of the top with respect to x is 1 times the bottom minus x times the derivative of the bottom. Derivative of bottom is y prime, right? Derivative of y with respect to x is dy dx, or y prime, all over the bottom squared. And then here, the derivative with respect to x of 7y, 7 is a constant multiple. Derivative of y with respect to x, again, is y prime. Okay. So cleaning this up, I got 8 x times y prime. I'll put the y prime at the end, minus 8y, y minus xy prime over y squared. This one's over x squared. So they're just cleaning that up. Now, what I'm going to do is I'm going to get rid of my fractions. I'm going to multiply, and we do this with rational equations a lot of times. I'm going to multiply both sides of my equation by the quantity x squared times y squared, which is the least common denominator of my fractions. Okay, and that's going to get rid of the fractions and help clean things up a little bit. Okay, and I can do that provided x and y are both neither one is 0, which obviously must be the case since the original relationship we're dividing by x and dividing by y. Okay, so multiply both sides by x squared y squared. And when I multiply this by x squared y squared, the x squared cancels, and I'm just left with y squared times the numerator. Here, when I multiply x squared y squared by this, the y squared factors will cancel, and I have just x squared times the numerator. And then I have to multiply this one by x squared y squared. Okay. Now what I'm going to do is I'm going to distribute the y squared through here and the x squared through here. Again, my goal is to solve for y prime, and so I need to do that because I need to separate these terms here. One has a y prime, one doesn't. So I've got y squared times that gives me 8x y squared y prime. 8y times y prime is 8y cubed. X squared times y. And then x squared times xy prime is x cubed y prime. And then here I'll just bring the x squared y squared in front, put the y prime at the end. So here we have it. And then again, we're going to solve for y prime. So look at the terms that have the y prime in them. I want to get all those on one side of the equation, the ones without the y prime on the other. So I'm going to subtract the 7x squared y prime from both sides. So you can see that here, subtracting from both sides. And I'm going to add the 8y cubed to both sides and subtract x squared y from both sides. So I get all my y prime terms over here, and then I just factor out that y prime from each of these, right? And that leaves this left over. All right, and so to solve for y prime times all this equals this. I'm going to divide this by what's in the parentheses here. And there's my result. If I can simplify, I would like to, if I can factor up top. Notice there's a greatest common factor of y. I can factor out a y from those two terms. And down here, I have an x that's common to all, factor out of x. What I'm left with can't be further factored. Not really much more to go there. So either one of these would be a fine final result. Again, and when we do these implicit differentiation problems, our derivative will often be in terms of x and y. Okay, I hope this is helpful on this one.